given a polynomial and one of its factors, find the remaining factors of the polynomial. So we are doing synthetic division to find the quotient, like yesterday, but then we're also going to factor further to find the rest of the answers. Okay. So if we take a look at number 13, we have x to the third plus 2x squared minus x minus 2. So are all of the powers accounted for? 3, 2, 1, nothing. So we're good to go there. And what we have is a factor that we know does definitely divide equally, because if it's a factor, you get a remainder of 0. So that's our factor. To set it up for synthetic division, I like to, again, take that divisor, set it equal to 0, subtract 1, and this is the number that goes into the box here. And I draw my little picture, and you've got room down on the bottom of the paper if you want to do it there, or on the back. You don't have to use, or you can use another sheet of paper. We put that number in the box, and then we take the coefficients from each one of these. So I wanted to point this out because some people, several people were putting, if they had x to the third like this, instead of just putting the coefficient here, they were putting x to the third here. So what is the coefficient on x to the third right there? It is a 1. So we need to make sure that we do that. So we're going to put a 1, 2, negative 1, and then our constant will go on the outside. Remember that the answer here will be the remainder. If you know it's a factor, you know that answer should be 0. So you do know it's a factor. And then this will be the answer on this side. All right, so take the first one down. We multiply negative 1 times 1. And put that up there. And then we add. And then we take 1 times negative 1. And then we add. And take 1 times negative 2. That makes 2. And then we add. And we get 0. So the point is that you're going to do this just like yesterday so that you can find this answer. But what we're going to do now is find the rest of the factors using that answer. So there's a couple of different things you can do. We need to rewrite it so that we know that was x to the third, so this one becomes x squared plus 1x minus 2. There's no remainder, so this is our new function that we have. And you can do a couple things. You can factor if it's factorable, or you can do the quadratic formula. I don't know what you prefer, but we're going to do both.
Why do we add 2?
We took negative 2 times negative 1,
Okay.
and that makes 2,
Okay.
and we always add. So we
And
did
we do
that.
it like that. Or would we have,
So this is the quotient for the first division.
so what we gonna?
We're going to find the other factors now. So we know that one of the factors is x plus 1. We want to find the other two factors. What other two quantities like that will multiply together to make this? Okay, so the first option is we can factor, so that we factor it like this, where we have two different binomials like that. And when I factor, I look for what multiplies to be negative 2, and then adds to be 1 here. But to take x times x, that gives me x squared, so I get x times x. What two numbers multiply to make 2? 2 and negative 1. Let me just start with 2 and 1 first.
Yeah.
And then if I want it to multiply to be negative, one of them have to be negative, but we want it to add to a positive 1 here. So we're going to make this 2 be the bigger positive 1, and make that one be the smaller negative 1. So these are the other factors that make this. So if I wanted to then write the final answer, what's the final answer? It is x plus 2 times x minus 1 times the original x plus 1 that was in the beginning of the problem. So these are the three factors that make this work. If I multiply these all back together, if I FOIL this, and then I FOIL it with that, I will get x to the third plus 2x squared minus x minus 2. So those three, if you want to consider them as zeros, when I make the graph of this picture, this graph will have 3 zeros that will cross through the x-axis at 3 places, or at least touch at 3 places.
What's the second option?
So the second option, if you're not very good at factoring, is the quadratic formula, which is a formula that's very specific and straightforward, so you don't have to worry about issues. So quadratic formula and minus square root of b squared minus 4 times a times c divided by 2 times a. Where we would take this function, answer, that's a, that's b, that's c, and then we would plug it into this. So we'll get the same answers, it just takes a little bit of work. But it is a very specific and straightforward way. So if b is positive 1, then we would make it be negative 1 plus n minus. B squared would be 1 squared. And then we take 4 times a is 1, times c is negative 2, divided by 2 times a, and a is 1. So this one is really straightforward. There's no questioning what I need to do here. Factoring for some people will be more efficient if you can do it well. If you do that star method too, you can do that. If you like to factor that way, then factor that way. It's up to you if you want to do it. You'll get the same answer as that. But on this one, we simplify negative 1 plus and minus 1 squared is 1. Negative 4 times 1 times negative 2 is 8 over 2. We get negative 1 plus and minus the square root of 9. What is the square root of 9?
3.
So we have negative 1 plus and minus 3 over 2. Keep simplifying so that you get to that final part. And that'll be negative 1 plus 3 divided by 2. And negative 1 minus 3 divided by 2. And that will give us 2 over 2 is 1. This one will give us negative 2. These are then the zeros. So to write the factors, I take the opposites of them. So if this turns out to be a positive 1, we switch it. This turns out to be a negative 2, we switch it to make the factor. So these are the zeros. These are the factors. So we write them back into them. That's the only difference between this method and this method, is that this one just gives you the factors straight away, but this one gives you the zeros, and you have to change them back into factors.
Okay.
Okay.
Can you repeat how you factor?
Yep. So factoring, I don't, you want to figure out, if I do this, you're looking for, this is a formula that some teachers teach here that you can use. And what we do is we plug in a times c, so we take 1 times negative 2 and get negative 2. And then we take the b from here and put a 1 here. And then, so this is the multiplication part, and then this will be what it is. A is 1, A is 1, and then we say what multiplies to be this, but adds to be this. What are two numbers that multiply to be that, but add to be that? So multiply to be negative 2, but add to be 1. The only way to get 2 is 2 times 1. So we would do negative 1 and 2. And so when you write this as a factor, because this reduces to just 2 and this reduces to just negative 1, then we write factors as x plus 2 and a factor as x minus 1. Because we get a 2 and a negative 1. And this is a method that people use. I'm just a guess and check kind of person. So I say, I know that if I take 2 binomials times each other, to get x squared, I take x times x. And to get negative 2, I have to take a 2 times a 1. One of those has to be negative. And then I need it to add to positive 1, so I make the 2 be positive and the negative be the 1. Because that will make this, if I add 2x and negative 1x, that gives me positive 1x.
And why you wrote a plan on it like that?
Because these are 2 of the factors that come from this, and then that's the first factor that I gave you.
Also, you have to add that.
Yeah, so add that one back in. Yeah. So you're just finding the factors today, and I'm going to take you through this again. Do you like factoring? Do you like to try to factor versus quadratic formula?
I like my quadratic.
Okay, so you are welcome to do the quadratic formula, but remember that when you get those zeros, you've got to convert it back into a factor by switching the sign, yeah.
So from 23 and 24, would we have to
Yes. 23 and 24, are they not factorable?
No, you
said
said
they
saying
were.
that we should probably have to do synthetic division.
Oh, I would probably do long division on 23 and 24 before, but then you could do factoring after that. The only reason on 23 and 24 that you would do long division as opposed to synthetic is because it's 3x plus 1 instead of just x plus 1.
That's
We can do that one if you want, do 23.
me.
And then. So 23 is definitely a bigger problem because it has more numbers. And this is 3, 2, 1, and nothing, so we're good to go there. And we're dividing it by 3x plus 1. So that quantity starts with a 3 instead of a 1, which can create an issue if you're trying to do synthetic division. So I just encourage you at this point to do long division because it will be more efficient and less work in the long run for you. So we'll take 3x plus 1.
And that will the semicolon always mean divide?
Yes.
That's weird.
And it's because it says that, given a polynomial and one of its factors, find the remaining factors. If it says to do that, that means divide. Find those and divide. Alright, so 3x to the third plus 4x squared minus 5x minus 2. And remember that this long division really is just like dividing back in the day.
Seems really difficult.
So we have 3x squared as our first part of this polynomial right here. 3x squared, or we want it to be 3x to the third, but right now it's 3x. So what can I multiply 3x by to get 3x to the third?
X to the
X
second.
to the second. Because there's already an x and there's already a 3, we just need 2 more x's, so we'll multiply by x squared. And then remember that this is a quantity out here, so x squared has to multiply by both of those. So we take 3x times x squared, and get 3x to the third, and x squared times 1, and we get that. And in long division, unlike synthetic, in long division we subtract once we get those answers. So this right now is positive and positive, that becomes negative and negative, because we're subtracting these two, so that this will cancel out. And then 4 minus 1 will be 3, and then x squared, and then bring down the rest. Okay,
That's what?
so we do that subtraction and we get it. Then we start over, because we aren't done yet. 3x squared is what we want. This is 3x. I can do something to make 3x become 3x squared. What can I multiply it by? Just an x. So that adds an x up here to make that finish. And then x times 3x is 3x squared. X times 1 is 1x. And again, you're subtracting, so this becomes a negative and this becomes a negative. Those cancel, and that is negative 5 plus negative 1, negative 6, and then bring down minus 2. And it is a factor, so we should get 0 at the end, right? Factors make 0 remainders. So 3x times what makes negative 6x?
2.
Positive 2? Negative 2. Because we want it to be negative 6. So this would be minus 2 at the top. And then negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. Both of those are negative right now, so when I subtract this,